Hello everybody, Keith here. Today I thought I'd try something new, and usually when I do these kind of tech videos I have everything planned out in advance. Well, today I'm just gonna wing it. I had an idea this morning that I have this Arturia MIDI controller, and that's great, but it would be neat if it was its own standalone instrument. So what a MIDI controller does is it generates MIDI notes, and then it sends it to somewhere else that can generate sound or control other instruments or pedals or things that can generate sounds. So I thought it would be neat to see if I could use something like a daisy seed here to open this up, do a little bit of DIY, and get this to be able to just plug it in and play it and have it generate sounds. Something like my synth that I made over here, except a little more in a nice commercial sort of package on a keyboard. And I thought that would be neat because my kids, I think, would enjoy playing something like that. So I haven't really done much thought other than come up with this initial idea, and we will see where it takes me. So the first thing I need to do is open this up and see what we're working with on the inside. I think it sounds like it has a bit of space in here to work with, but there's a ton of screws that I'll have to take off, and well, we'll figure it out together. I have another MIDI keyboard by Arturia. It's this Keylab 37, but I actually use this as a MIDI keyboard a lot, and I don't think there's as much space in there to sort of jam in some extra electronics. So I think this is the one that I'm going to go with. Let's see. Alright, I guess I'm just going to start taking out screws and hope I don't break anything important. Whew. There are a lot of screws in this, and some of them are quite tight. And it's time for a coffee break because it's a Sunday afternoon. That's what I'm doing. I think I'm breaking a sweat getting these screws out. Alright, continuing on. Oh, probably should remember where these all go because they're not all the same size. All right, second coffee break. I think I've got all the screws except this last one, and then I'm gonna see if this back panel will come off cleanly. This should be interesting. This isn't a very expensive piece of hardware, so if I do break it, I'm not totally distraught. That would make me sad, but I got it used for maybe $120, and new I don't know how much they are, maybe $150 or $200. Okay, so that is all of those screws. Let's see if I can I think I'll probably have to get another tool. Oh, something is loose. Something is very loose on the other side. Oh boy, this keyboard seems like it's about to fall out. Oh boy, this is a fun adventure that I've taken myself on today. Let's see, I'm gonna get something that I can see if I can wedge this out of place. Okay. There's not a lot of give on the corners or around the edges here. Oh, but it is, the plastic is bending. Let's flip it over and look at the other side. Maybe I'm missing something. All right, okay, I think this will come right out. Oh yeah. Nope. There we go. Okay. So there's the keyboard, and it's connected by this ribbon cable that I want to be careful not to yank out. There's the back of it. Okay, and now from this angle, don't try this at home, you're gonna break your stuff. From this angle, I can push this out a little bit, but it's still stuck on something. What is it stuck on? Oh, you know what? I bet these are connected somehow and holding it in place. So before I totally break this, I am gonna take a look at it and go a little bit slower. Always good to slow down and just look at things for a minute. This is pretty cool. I wasn't really sure what was inside this. It looks like they have these springs that provide the tension for these keys. Got some diodes across here. Yeah, it'll be neat to see what all is inside this. So I think I noticed I can just pry this off. Oh yeah, oh yeah. There we go. Yep. Slow but steady. Yep, there we go. Coming right out. Okay. Yes. And there goes the whole back panel. Nice. Go over there. Okay. Now we can see what we're working with. Well, the good news is it seems like there is a lot of space that maybe I could fit an extra chip, maybe a PCB, and then have an audio output, drill out the plastic, put something there. So we got a ribbon cable connecting the keys to the main board. We have a microcontroller board, a couple boards in here. What is that? Looks like a ST microcontroller chip. And another subboard underneath that, which I probably won't have to mess with. And then what I will need to get to though is this MIDI connector. I'll need to figure out which one of these to connect to my Daisy Siege. So I'll have, what I'm gonna do is have this MIDI output, hack into that, have it go into the Daisy Seed, and then the Daisy Seed will receive the MIDI notes and any controls to change the sound. And then this will do all the processing and also send the audio output. And I would also love to be able to do what I did on this and put a little microphone on there and make a sampler like that, the Chompy keyboard, or there's a bunch of other ones, but the Chompy is the one that I have been looking at lately. Well, yeah, that wasn't too bad. Getting our hands dirty with stuff, breaking things, trying not to break it too bad. All right. Well, I think I have seen what I need to see. I'm going to take a few reference pictures and then decide what I want to do next and make a good plan for this new instrument that I'll be making. All right, I've done just a little bit more thinking about what all I'm gonna have to do to get the daisy seed in here. And I'm going to I think I need to get a better look at this connector board, which has our MIDI output and also the USB-C connection, because I'm gonna need the power, the 5 volts and ground connected into that what the MIDI-C is providing to the keyboard. So I'm gonna take off this and try not to lose any screws. Something else I noticed is that this board down here has a little, what I think is an NPR chip, because it uses, on the other side of this is the touch sensor, which does pitch mod. Or if it's not an NPR 121 chip, then something that provides that kind of touch functionality. All right, just has those 3 screws. And let's see, what are you? Okay, so we have the ribbon cable, which gets all the connections over. Ah, neat. Here's our MIDI output. This is a control jack. You can use it for a sustain pedal or something like that. And then our MIDI-C, which is a fairly sturdy connection. I think there's an extra connector on the outside that provides support, mechanical support for that. We have a power regulator, an LDO, some capacitors, probably related to power filtering, a couple of transistors maybe. Very cool. And then underneath that, it looks like there's a few more electronics, some capacitors, possibly a power circuit, some diodes. Okay. Very neat. Alright, so now I'm going to think about where I want to place the daisy seed within this board, how I'm going to hook it up, if I want to make my own custom PCB to put the daisy seed on, or just solder it, wire it, and make it messy. So next time I will be back with a little bit more of that plan. All right, now I need to figure out how I'm gonna power the daisy seed from inside the Keylab. So what I'm gonna do is I'm gonna use this voltmeter and check a couple points and see where I can find appropriate 5 volt power. So I just plugged it in and there it goes, turned on. At first I was thinking maybe I'd pull 5 volts from this point on the MIDI connector, and then quickly realized that won't work because the 5 volts going there doesn't have near enough current to drive the daisy seed, and it could interfere with MIDI, which is not what I want to do because I want to use MIDI. So I have it set to looking for DC voltage. I noticed all of these screws are grounded, so I can use that as my ground point, and I'm just gonna go up here and check at this point to show you that it is 5 volts, but it wouldn't have enough current there. So another thing I noticed on this board is it has some of these, you can probably barely see that, these tiny metal points, they're test points that they can use, I guess, when they're building this thing or developing it. And so I'm trying to find somewhere where I might find power. So I'm thinking 5 volts is coming from this, from the USB. It's got to go through this ribbon cable and onto this board somehow. So I'm just going to test out and look at this point up here. And we got 3 volts there. Now I'm going to test this one. 3 volts is not enough to drive the daisy seed. That one, oh, that's 5 volts. And then these capacitors probably connect. Yep. 5 volts there on that capacitor. So I could solder my power to one of those points probably. But the best test is to actually hook it up and see how it goes. So I have the power pins just temporarily soldered on to the daisy seed, and I'm going to connect ground there and 5 volts that we just found and see if it powers up. That is a good sign. So the LEDs are on. It seems to have booted up. I can do some other tests, like try and load some software onto it, make sure it gets recognized that way, but I suspect it will work. Awesome. Well, there is my power. Plug that before I do any damage. And I was looking around for places to put the daisy seed in here, and I think it's gonna have to go somewhere over here. More on that later. All right, it's been a few days, and I've decided what I'm gonna do for this modification, and I am going to design a PCB that will fit right here. The daisy seed will go about right there, and then my microphone will go over here, and that way I have some access to the other side. I can drill a few holes for this microphone. I can drill here for USB, and I think I'm going to be able to use these 2 mounting screws to connect my PCB and have it be very sturdy. And then I'll be able to connect up to my power and MIDI, and then I'll have my audio out going somewhere up here. So the next step is to design that PCB. And I think I'm going to go with a simple through-hole board. I have all the components for the MIDI circuit and for my microphone, and it should be able to fit fairly simply in this space. Well, here is my reference picture that I used to help design my board, and where the major components will sit. And here is the board I designed. And I made some crude measurements of this space, and there's a few things that I need to be careful of when I mount the board to these 2 screws. And that's, I need to avoid this piece that sticks out, and also any interference with this outside board. And I think this will work, and I've oversized the slots and the screw holes so that there's a little bit of room for error there. And I've also added a 3rd mount. If I want, I can drill through this plastic on the other side of that and have it be extra sturdy. So let's look at the schematic. And it definitely could be better, this design, but I think this will get the job done. So I have my daisy seed with all of the necessary connections, power and ground, and then I have my MIDI circuit. This will uses a octocoupler, which will take in that MIDI signal and convert it to something that is appropriate for the microcontroller on the daisy seed.
And I also have my microphone circuit with some power filtering. It's drawing power from the 3-volt analog output on the daisy seed, filtering that, and also there's a capacitor on the audio out going into the daisy that will bias that back to 0. And then here's my PCB layout. Nothing too fancy. It's a 2-layer through-hole board. That way it's cheap to make. You could do an SMD board with all of these components, but that would make it a bit more expensive. And then I have all of these pads for soldering wires to. Got the MIDI connection up here, and that will go to these pins 4 and 5 on the MIDI. And then my stereo audio output, and then my power, which will go under there to that 5-volt point that I showed you earlier. So I went ahead and I ordered this board from JLC PCB, and it ended up being about $30 total. The PCB itself was like $3 for 5 of them, but shipping was the remaining $25. I also looked at Park, and it was going to be about the same price. I think it was $25, but it would have taken a week or 2 longer, I think, to get it. So I went with JLC PCB. So yeah, I'm excited to get this board in about a week and see how it fits, solder it up, and then we're running. So I was thinking I would show you real quick what it's like to order a board from one of these manufacturers, because a lot of people, even if they are familiar with electronics, may not have gotten PCBs manufactured. So this is JLC PCB, and it's really probably about the easiest option for getting boards manufactured. So I'll just run through the process real quick, what you would do. So you go to order, and then you add your Gerber file, which that is a output through KiCad. This software is KiCad, by the way. And to get your Gerbers, you go on your PCB editor, fabrication outputs, and Gerbers. And each manufacturer has their own requirements for what options to check here. So you would plot those and also generate drill files to make that. And then you put it in a zip file and then just drag and drop. And these are all your options for making your PCB. Normally I stick with pretty much the default because that's going to be the cheapest, except I will choose a different surface finish. For this board I chose lead-free HASL. For my assembled boards I will use ENIG, which is more expensive but a nicer finish. And as you can see, there's the board and $3. So it's really cheap to make these. Once you start doing assembled boards, it does get more expensive. And then you save it to cart and order, and that's it. You'll get some updates through their process, and I think it'll be here in a week or a week and a half.
Alright, since I last took video of this, I have decided to go in a different direction with this project. Instead of having a line out, I think I'm going to use this audio amplifier and speaker setup. And I found these on Adafruit, both the amplifier and these mini speakers, which actually sound really good for their size and price. And I've tested some firmware on the Daisy Seed for a simple synthesizer. I haven't tested out the microphone over here yet, but I'm planning on making a little wood enclosure for these to be housed in. The wires will go out of what I previously used as my line out and then connect to that mini speaker cabinet. And I think I'm gonna try and mount it on this somehow, maybe just with some super glue or something like that. So we will see how that goes. But so far this is shaping up to be a pretty cool standalone instrument. I also wanted to explain that I could design this so it has both a line out and the speaker, but since I already have, I can do this on my SoundSketch or my Funbox platform and do this MIDI stuff for recording. For this, I really want to keep it as just this standalone instrument that you can plug in a USB and it'll make sound. I think that would be the most straightforward and the most fun for me and my kids to play with. But it looks a little bit messy right now, but I will clean that up and get it looking nice. And here is the final configuration. I did end up making this wood enclosure, which I'll show you the front of in a minute. I've got my speakers in both of these. I'll probably close this off at some point, but for now I'm going to leave it open. I have my amplifier here going to the speakers. I put a lot of electrical tape to kind of keep things secure. And I also drilled out a hole for the USB, and I put a hole in the back of this so I can press the boot and reset buttons on the Daisy Seed. That way I can put this back panel fully back on and be able to program without having to take apart anything. So hopefully this will be the last time I really look at the inside of this, and it will continue working well, and I'll just work on the programs for making synths and using the microphone. Hopefully that works. I haven't tested it yet. And now I'll show you the front of this thing, what it looks like. And here is the front of it. As you can see, I just mounted this sort of cabinet directly onto the Arturia MiniLab, and I did that with some screw holes that go straight into the plastic. I used 2 of them, and then I just used super glue to keep these in place in that enclosure. So yeah, I'm excited to see how it sounds. Now for the sound test. I loaded a program on here onto the Daisy Seed that has a subtractive synthesizer and also an FM synthesizer. So I'm going to test both of those out now. Nice. Now for the FM synth, I select by pressing that pad. So the next thing I want to do is write the firmware that uses the microphone and takes samples and behaves like a chromatic sampler and assigns the sound you record to your keys, like on my other synthesizer. I verified that the mic does work. I did that by in the program testing the input and seeing if it comes out of the speakers, and it did. So the microphone circuit does work. I just need to write the code to do that. Well, 2 weeks ago I had an idea, and today I'm holding that idea in my hands. So that's pretty cool. And that's the great thing about working with electronics and music and DIY stuff. After a while you get a feel for what you can do, and you can come up with some interesting things just by daydreaming. Thank you all for watching.